Rivers and Flooding, Chapter 9. Water covers about 70% of Earth's surface, and flood causes a significant hazard to human life and property. The number of people killed or affected, along with economic loss, is the greatest in Asia. A monsoon refers to a seasonal shift in air pressure and precipitation patterns. Dry winters to wet summers. August of 2010, the greatest monsoon rains in decades caused catastrophic flooding in Pakistan. This killed about 1,600 people and 20 million people were affected. The population of Pakistan has grown from about 34 million to 170 million. Most people in Pakistan live closer to the river. About 20% of Pakistan was flooded in 2010. We need to rethink our philosophy of how we adjust to the flood hazard in the United States as population continues to grow. This can be a huge problem. We need plans for future flood hazard reduction that do not require massive evacuation from flood-prone areas. Avoid the hazard through land use instead of massive evacuation. This picture shows you areas with heavy flooding July-August 2010, Indus River. This is where Pakistan. For more than 200 years, Americans have lived and worked on floodplains, depending on soil, water supply, ease of waste disposal, and the commerce. If the floodplain and its relation to the river are not recognized, flood control and drainage of wetlands become prime concerns. The pioneers moved west, modifying the land, cutting and burning the trees, and then modifying the natural drainage. Parts of the hydrologic cycle. I think you have learned about hydrologic cycle. If not, it's also known as water cycle. You talk about the precipitation. That means the water coming to the surface as the form of water, ice, or hail. And then it's runoff through the streams and eventually getting into the ocean or lake basin, and evaporation of the water, and the evaporated water vapors, they condense and forming clouds and bringing back the precipitation. So that's called the water cycle basically. And also we need to talk about the groundwater portion of it. So streams or small rivers. So there are a couple of components that you need to understand when it comes to river. River is usually it's a network of streams. And there's a watershed or drainage basin to begin with, especially in mountain areas. The base level and slope and gradient is associated with the river components. So here's a picture of a drainage basin, and this is the drainage basin boundary, and you can see these little streams come together and forming the major river. And eventually this is where you are talking about the delta, where river is dumping into the ocean. As this is mountains, is highland, and this is lowland or coastal areas. Stream total load. That means the total amount of sediments that are transporting through these rivers. There are three categories of the stream load: bed load, suspended load, dissolved load. Coarse particles moving along the bottom of river channel, less than 10% of the total load, is known as the bed load. You can see rolling of the particles, jumping of the particles. And the suspended load accounts for about 90% of its total load and makes river look muddy. So this is suspended within the water. Dissolved load means carried in chemical solutions, like you're talking about cations or anions mixed up with this water, and that's also bringing with these streams. Here's a picture that you can understand the dissolved load. mostly the cations, anions here, or anionic complexes. And here you can see the suspended load. This is what you're going to see if you take a beaker of water from a river. When it settled down, these gravel particles, sand particles, gravel at the bottom, so that's basically your bed load. The suspended load is what you're going to see, the turbidity in your water that represent the suspended load. That means the dissolved silt and clay particles within the water column. That is suspended load. Stream competency and capacity. These are two important words when you come to talk about streams or the rivers. The competence is measuring the maximum size of the sediments transported by a river. If I say competence is higher at mountainous areas, that is correct. Because if you think about that, the water can push big boulders at mountainous areas. But you don't see big boulders in deltaic regions. When it comes to capacity, that is total amount of sediments a river capable of transporting. So capacity is higher at a delta. That means you can see lots of material, like fine-grained material, dissolve within that water. So this is why you can see, you don't even see the water or the movement of water. It's very muddy. And you don't see boulders here. But the capacity is very high in a deltaic region, but capacity is very low at mountainous area. You will see very clear water at a mountainous area. This is the chart just to simplify what we just discussed. Capacity, competence. The large, slow, muddy river, capacity is high. Example, delta. The capacity is low, small, fast, clear stream, like young age of the stream is low capacity. You can see clear water. The competence, the size of the particle that the stream can move is in here is very small, very low. When it comes to the deltaic region, you cannot push the boulders at delta. The speed of the water is not strong enough to push boulders at a delta. So you're talking about the pushing mud particles, silt size, clay size particles. When it comes to a mountainous region where the high energy river, I should say, like a very young age of the river, can push boulders because of the high energy. So the competency is higher at mountainous areas. River dynamic characteristics. So we need to talk about some river dynamics. The discharge, you may have heard about this word, especially when it comes to groundwater, hydrogeology, or something like water resources, people talk about discharge. So what is the meaning of discharge? The volume of water passing through a given location of a river per unit time. So Q is the discharge, W width, D is the depth, and V is for velocity. If you see this picture, you can see the width, depth, and the velocity of the river. And here as well. So if you calculate this and if you think about this equation, so water cross section multiplied by the velocity. The water cross section comes with the width multiplied by depth. So it's basically right here, 3 meters, 10 meters in this example. The 3 meters would be depth, 10 meters would be width, and that's going to give 30 multiplied by 1 meters per second. So this is 30 cubic meters per second is the discharge for this particular river A. And river B, you have 9 into 10 is 90. That's into 2 is 180 cubic meters per second. So discharge is much higher in the picture B or the river B. Gradient. The vertical drop over horizontal flowing distance expressed in percentage, feet per mile or degree of the slope. I think it's pretty clear and easy to understand. The stream velocity is also largely depending on stream gradient, discharge, channel shape, and turbulence. When it comes to turbulence, what is turbulence? Sometimes these currents can move very diverse directions where you develop this turbulence. The velocities are unpredictable, like very high velocities and in every which directions. So this is where you're going to talk about higher velocities in your stream. And also if you have high discharge, like if you think about flood, the more discharge comes in and then the velocity of river automatically increase. And also channel shape, if you have very narrow channel versus wide channel, that changes the velocity. If you have a wide channel, the velocity will be lower compared to the narrow channel where you can expect to see higher velocity. River erosion. There are different erosion types that we would like to talk about. The abrasion by sediments transported by river, that's one type of erosion. Hydraulic action of moving water, and also chemical corrosion. Example, carbonates can get dissolved if you have little bit of acidic water within your river. So likewise, these different types causing the erosion. Erosion is one of the most important Earth's external processes. There are three major Earth's external processes: weathering, erosion, and mass wasting. So erosion is basically, the meaning of erosion is the movement of sediments from one place to other. In this case, the movement of sediments from one place to other by the water. In erosion location is down cutting or lateral. If it's lateral, the concentrating on the outer bends. If you look at this picture, the more erosion in here. It's high speed and taking up the sediments. The river erosion effectiveness, that also depending on the stream velocity. If you have high velocity, then the erosion is more effective, and also higher stream discharge will cause higher erosion. Stream load, that's the other thing. If you have much heavy stream load, the erosion is less likely happen. Instead, it will happen more deposition. And the nature of the rocks, if you have more and more granitic basement and more granitic rocks around or igneous rocks around, that it will be very unlikely you can expect to see much more erosion. But if you have more sedimentary rocks, then you can see very high erosion because the rocks are weak and they tend to erode easily. Also regional topographic relief, high relief versus low relief causing the erosion. The base level and the climatic conditions. If you're exposing to high rainfall and higher sunlight, you will have more and more erosion. That's why if you look at the soil map of the world, so you can see more and more soils and more erosions closer to the equator region where you have more moisture and more sunlight, where you have more weathering and more erosion. The river sediment deposition. Once you have these eroded sediments, they should be deposited in some place. If you think about the river, from the beginning of river to the end of the river, the younger river is very energetic and erode the material super fast, and they're bringing all these sediments towards the ocean basin. And not only towards ocean basin, maybe at the delta you can see higher capacity, as I mentioned before. So higher capacity of sediments, and they tend to deposit because the velocity is extremely low. As you can see in this slide, the flow of a river slows down, example at delta, so that decrease the stream gradient, decrease the velocity, decrease the discharge, and change the channel shape. The channel become much wider. If you look at the Mississippi Delta, you can see the channel become much wider. It's not a narrow channel. So where the velocity becomes really low. And the change in the amount of stream load is another factor affecting the depositional conditions. And also change of geological setting, like example rock type along the river banks, can cause the changes of the rate of the deposition. If you can see in this picture the same diagram, but here you can see much deposition in this place, the point bar deposit right here. The deposition features, there are different types of depositions when it comes to river sediment deposition: floodplain, natural levee, point bar, alluvial fan, delta. So these are important features, but they refers to the deposition of sediments in with respect to the river. So these are related with the river. So the floodplain, natural levees, like natural banks or the little dams, the levees, the point bar deposits, like I showed you, these are point bar deposits at this curved or the meandered channels. Alluvial fans are the places you're going to dump the sediments into from upland to lowland, and the deposition of these alluvial deposits. And the delta is where you are dumping the sediments to the ocean basin from the river. Ever-changing processes like time and rate of erosion and deposition. So these both needs a balance sometimes. So some places you get more erosion, some places you get more deposition. Sometimes erosion is faster event compared to deposition. So that's why we have a lot of problems, especially when it comes to coastal erosion. The beaches are not producing as the same rate as the coastal erosion. So that's why that become a big environmental problem. So reasons for the changes is complex but related to changes in river channel, width, depth and slope, and also the composition of channel bed and banks, vegetation cover that also determines the time and rate of erosion and deposition, the variations of weather and climate pattern, and also human activities, especially the land use changes can cause the changes in time and rate of erosion and deposition. The effects of land use changes. The changes in infiltration rate. So what is infiltration? The percolating of water from surface towards the groundwater table. So the infiltration happening when water particles moving through the soil particles and reaching the groundwater table. So that's the simple understanding about the infiltration. The change of the amount of water flowing into a river that changes the effect of land use changes. So the soil erosion is change in the amount of sediments in a river. The amount of water and sediments in river, so that changes the velocity of water flow, and the changes in river's velocity that leading the change in river dynamics. So we briefly talked about this same concepts in previous slides. The forest to farmland. So people cut down trees and forming farmland, so that increases soil erosion and stream deposition, increases gradient and velocity, and increases the river channel erosion, because you're getting rid of a lot of roots that are holding this soil mass and exposing to the rainfall. That's going to cause a huge amount of soil erosion and urban buildup, especially you're forming the impermeable covers like concrete, so there's no way that water can percolate through. So that's going to be a huge problem. The water then going to be accommodate on the surface, and that can cause a lot of erosion, and also increases lower magnitude flood frequency and reduces the lag time of flood. So braided, if the river's longitudinal profile is steep and there is an abundance of coarse bed load sediments called braided channel. I'll show you a picture in next slide. The braided channels tend to be wide and shallow compared with meandering rivers. These are associated with steep rivers being rapidly uplifted by tectonic processes, or rivers receiving water from melting glaciers. If you go to Grand Canyon area, the canyons, you could be able to see this kind of the both meandering and the braided channels. The meanders migrate laterally by erosion on the cut banks and by deposition on point bars. Meandering channels often contains a series of regularly spaced pools and riffles. So this is a picture of meandering stream versus braided stream. The meandering streams, fine sediments, relatively constant flow, and dense vegetation. When it comes to braided stream, the coarse sediments, much of a bed load, and variable flows. So you can see it's moving here and there, and sparse vegetation. River flooding. So flooding, what that means, the overbank flow condition, discharge greater than channels holding capacity. So when it comes to rivers, you have certain number of holding capacity, like any other thing that we're talking about. So that's overcome of this discharge over that carrying or the holding capacity. The stage means the height of the water level in a river at a given location at a given time. Hydrograph means the graphic representation of a river's discharge over time. Lag time is the amount of time between the occurrence of peak rainfall and the onset of flooding. So these terms are important when it comes to the measuring the floods. You look at this picture, so this is flooding data measurement. So you have hydrograph right here with the time in x-axis and the discharge in y-axis. And here you can see stage versus discharge is plotted, and here the stage versus time is plotted. So that the definitions that we just defined are very important in order to make sure that we understand the data collection from floods. The frequency and magnitude of floods. We use recurrence intervals, that is in this equation R equals n plus 1 divided by m. N as the number of years of record, m is the rank of individual flow within recorded years. The probability of a given magnitude flood is P equals 1 over R. R is again recurrence interval. The statistical probability versus reality is something that we need to talk about. So statistically we do these calculations, but in reality this can be deviated. So that's why we're always talking about error margin when we do these measurements. The probability, 1 25-year flood on average once every 25 years. In reality, 2 25-year floods can occur in 2 consecutive years. So that is the difference between the probability versus reality. Types of flooding. The types of flooding is determined by the stream location, duration, magnitude, or recurrence interval. The upstream flood, the shorter duration in small area. Downstream floods, normally longer duration, greater magnitude, larger area. And flash floods, high volume of flooding water in very short duration. Characteristics, short lag time, usually in upstream, versus non-flash flood. It's longer in duration. Magnitude and recurrence interval also a factor to determine the types of flooding. 100-year flood, 50-year flood, 25-year flood, 10-year floods likewise. The factors affecting flood damage. The regional land use changes such as urban development, deforestation, soil erosion can cause the flood damage. The land use on floodplain is not a good idea, but we have done that, especially if you're living in Florida, so you have a lot of floods in there, so you may be living on floodplain in the area. Frequency and magnitude of flooding is important, and also lag time and duration of flooding is important. Sediment load is another factor, and effectiveness of forecasting, warning, and emergency management is also the factors affecting flood damage. urbanization and flooding. Like I mentioned, when you are increasing the population, you need more and more houses, more and more needs. So this impact on frequency and magnitude of the flooding. This increases in both frequency and magnitude, especially in small drainage basins. Impact on a reverse discharge, increase in runoff without increase in precipitation. So significant reduction in lag time of flashy discharge. That's kind of consequences with urbanization. So multiple of mean annual floods, you can see the impervious area, that means not permeable area. So why this is happening? Because we are running out of space where we can percolate the water through the soil particles, but we are developing more impermeable layers with the concrete. So that's why we are looking at number of floods over couple of years. And here also you can see the before urbanization and the after urbanization, and the lag time after urbanization is much higher. And also the discharge is much higher and the lag time is low. So that means you're going to get flood very quickly than before because of the development of impermeable layers. Nature and extent of flood hazard. The factors affecting the flood damage, the type of land use on the floodplain, the magnitude and frequency of flood, rate and duration of flood, season of the flood, population density, public awareness, effectiveness of forecasting, warning and emergency planning. So these are important factors affecting the flood damage, which we have already talked about. These are selected floods in the United States, and you can see how much property was damaged and number of lives lost. That's a disaster. This is more data. All right. Effects of flooding. The primary effects is the injury, loss of life, damage and destruction of property, erosion and deposition of sediments. Secondary effects, the water pollution, fire, diseases, displacement of people and interruption of social and economic activities. The structural approach to adjust to flood hazard. Physical engineering barriers, levee augmentation and the channelization, river channel restoration, and flood insurance, shared responsibility and accountability, and also flood proofing, raised foundation, flood walls, waterproof doors and windows, pumps. And when you think about the Mississippi flood, two major recent floods, 1973 and 1993. So in 1973, it was a spring flood, evacuation of tens of thousands, inundation of thousands of square kilometers of farmland, and nearly 1.2 billion in property damage. And 1993, it was a summer flood, century flood in magnitude from climatic anomaly, unusual precipitation and snow melt. Lasted from late June to early August. 50 deaths, 10 billion in damage. Levees can provide false sense of security. The floodplain regulations obtaining the most beneficial use of floodplains. The flood hazard mapping, floodplain zoning, the government buyout and relocating people from floodplain, and the personal adjustments needs to be discussed when it comes to the adjustments to flood hazard. Perspection of flooding, the individual level, the variable in their knowledge of flooding, anticipation of future flooding, and willingness to accept adjustments. So people needs to be aware. Public needs to be aware about this. Local and state level, the mitigation plans, and also federal government level, the mapping of flood prone areas, floodplain management plans, and public outreach. So you can advise people not to build up houses or any structures on the levees or on the floodplains that may cause future floods. And these are some critical thinking topics for you to understand. And with this, we are going to end the chapter 9.